I'm very honored to be here, and it's a fun topic. So I had a little time to think about this, and I was thinking, okay, keynote speaker, got to get everybody fired up, got to, you know, but it's such an easy topic to get people excited about. So let me just bring, I was thinking about, so how do you sort of look at the bounds that we were just talking about, how do you define wearables? And I think the bottom line is you don't. You let it go where it goes, and I'm going to talk a little bit about the boundaries and talk about a little bit about how we got here, but it made me think, the first thing that came to mind, you can see what I've been watching in my free time, you know, the ultimate wearable, right? Ultimate functionality, the Iron Man stuff, and then, of course, my favorite show, Star Trek. I almost made a mistake and put Captain Kirk up there, but of course he used the handheld communicator. It wasn't until we got Picard, until we got the wearable, so that was a last-minute save. It was just all, so that was good. Anyway, but then I thought, oh, the ultimate wearable, sort of maybe where wearables and implantables intersect. So maybe that's where we're going. That made me think of RoboCop, probably a bit on the extreme side, but he's got both. He's got wearables and he's got implantables. It sort of makes one interesting package, right? And then I saw this picture on the web and I'm thinking, okay, at a certain point, and I think we're starting to see that, and I'll bring it up in the talk a little bit, but the sort of the intersection of wearables and implantables, there's a researcher at Stanford that's working on contact lenses with an immersive display. There are folks that are working on, you know, sort of sensors that monitor brain waves. I'll talk about another one that monitors electrical impulses to your muscles that, you know, communicate to external devices. So I was thinking, when you think about, and we'll get to this at the very end, I figured since I'm a venture capitalist, I got to give you some insight as to how you raise money. So at the very end, I'll kind of have a couple comments about, you know, where do you put the stick? You know, how far out do you put the stake out there? Been there with you, it's the classic conundrum. If you do something relatively easy, then everybody says, no, you know, too much competition, too simple, everyone's going to blow right by you. And if you're a visionary and you plant the stake way, way out there, then everybody says you're too early, we're not ready, we can't fund you either. So I know you can't win. So I'll just set that up in advance. The deck is stacked. It is not easy to raise money even for wearables, but there's a lot of money out there. All right, so I'm going to give you a little historical perspective, and I thought the most important thing I could do is kind of give you a sense of why we're in this room talking about wearables, just how did we get here? And then talk about sectors and markets and some of the challenges that we've got to face and some of the things that people need to, I believe, that people need to think about. And then, you know, like I said, some tips for the future, maybe a few little investor tips. So we've actually been living with the concept of wearables for a long time, and I'm going to just show you some examples. But it's one of those very, I'm a wireless guy at heart, so I'm, you know, I'm sort of not, when people say, well, what do you do? I always kind of say embedded systems, and I think about, you know, if I think 40 years back, I was putting radios together with processors together with sensors, which is not far from what we're talking about here. So it's kind of been around for a very long time. And a lot of you have been working in industry, and there's all kinds of jokes about demos. You know, you give a salesman a demo, or they always break when the customer is there, you know, those kinds of jokes. But the reality is there are certain kinds of demos that people that are just, you know, they just engaging and seductive and sexy, you know, wireless things. You do something over here and something else happens over here. Look, Mom, you know, nothing in between. I guess I'm not sure I can explain that. I'm not really a psychologist, or really don't understand the sort of that context. But the fact is, there are certain kinds of technologies that just capture your imagination. And I think the wearables market is one of those. Kind of as an attempt at augmenting, you know, human ability, or augmenting our, what did I say here? Augmenting human senses, or pushing the ability, the limits of human abilities. And I think that's why it's exciting, and that's sort of what it touches on. So when I was trying to figure out how far back it goes, and if you come up with sort of a rough definition of wearables, and I'll go back to my embedded systems roots, and you say sensor, processor, comms. That really kind of started right after World War II, right? And if you think about, you watch all the war movies or whatever, but the bottom line is there were radios, right? And so people started to think about the concept of communications. And not long after World War II was the Dick Tracy comics where he had the wrist communicator. I wouldn't say, I'm not making a statement that that's the first place, in human history where sort of a wearables concept has come up with those sensor processor communications, but it's close. And then my favorite one, sorry for the bad image, but one of the shows that only some of us in the room, I'm sure a small fraction, are old enough to remember Don Adams in a show called Get Smart where he had the shoe phone. And keep in mind, this was right at the time of the beginning of cellular. And most cellular phones fit in your trunk or were great big suitcase things, and this was Hollywood's vision of where it was going. They only got us halfway there. They didn't envision 60 years ago where we are now, but a wearable, the shoe phone. And in the 70s, actually when I was in college, you had companies coming out with the calculator watches, right? And they were interesting. I'm not sure if they took over the world at that time, but they were certainly, sexy. There was a lot of images in the 80s of I was trying to get a good one of a backpack computer, because once we had computers, then everybody wanted to carry them with them, right? So you could do your computing sort of in real time, right where you are, anywhere. But this was, kind of an extended calculator computer on your arm, so I thought it was kind of a funky wearable, but there it is. And then this one is actually kind of hits me close to home. I worked in the early 90s, I was at Trimble Navigation. And I remember being in my office probably 1992, 1993, and one of the managers came over and said, "Oh, we have a meeting with Nike. They want to put a GPS chip in a tennis shoe." And I was thinking, let me just get back to work. Come on, And obviously we know now, one of the challenges, and I'm going to kind of sort of create a theme here, one of the challenges with a lot of technology is that there may be one component of the technology that sort of, it's the long straw and people say the short straw, but I was going to say sort of the leading edge of the overall solution. And the GPS chip was there, but it turns out maps were terrible, right? And processing was very expensive. And so even if you could compute your GPS position, what the heck would you do with it, right? I mean, if you remember back, in the early, I won't even call it a smartphone because it didn't have a phone in it, but the early Palms, right, with the handwriting recognition. And there was another company that never really even made it. It was attached to Go, the operating system company. And I'm trying to think, I can't come to mind right now, but it was kind of a PDA, or it was more like a tablet, but the battery life was 2 hours. So you couldn't do much, right? But it did really cool stuff, but only for 2 hours. So this is, again, one of these things. So back in the 90s, there were wearables that just really weren't that functional, right? Because the rest of the ecosystem didn't exist or wasn't really mature. The fitness straps that monitor your heart rate, we've seen those for a while. I'd characterize those as wearables. I mean, you could argue, do you say a wearable has to have an IP connection between the two? I'm not sure you have to go that far. And a comment was just made about Bluetooth doesn't count as a wearable. I don't know. Maybe not. Good discussion to have. But certainly, electronics with processor, sensor, and comms, it sort of fits. So why are we here today? What got us to this point where there's a wearable conference and kind of brings a lot of people in the room on a Saturday morning? There must be something. So let's kind of think through what's happened. Well, the first thing is, it's almost like, what happened when the world started pushing into space in the 60s. I'm a comms guy, double E, communication theory guy. And a lot happened when people said, okay, let's land a human on the moon. All of a sudden, a gazillion people started working on all of the problems. And then there were all these peripheral solution, there were all these peripheral technologies that built other industries. And all of modern communications theory all came out right, after right in the 60s when the space race happened, because people were trying to figure out how do you communicate signals long distances with low power, all the environmental stuff. There was a whole bunch of stuff that came out. Well, I think it's the race to get to handheld computer, ubiquitous communications has done kind of the same thing. And just, between display technologies, processor technologies, assembly technologies, we know all of the human interface, speech recognition, gesture technology, all kinds of stuff is kind of coming out of people doing research to try to figure out how to put it in these devices. So I think the wearables market in some small way has been accelerated by a lot of the things that have happened because of smartphones. Flexible circuit boards, this isn't as, some people would think so, so I have to be politically careful here, but the bottom line is it's a little bit of the behind the curtain technology, but even so, to have electronics integrated into your clothing obviously has to deal with environmental and physical stresses that you normally wouldn't get if it was a firm, hard package like a cell phone. So people doing research in this area have also carried the torch for us in the wearables area. Cloud computing. This is one that it's sort of everyday discussion now, but the reality is having data accessible in one central location from multiple points and then being able to draw that data at any time from anywhere, but in the aggregate, is a really big deal, right? And so that wasn't doable before for a whole bunch of reasons. Some of these things are interconnected. We didn't have the communications, we didn't have the storage, the processing was too expensive, we didn't have virtual machines, all of those things. But I'm sure there's some of the companies that are going to present tonight are probably going to talk about cloud solutions for aggregating wearables data. I mean, it just makes sense. So this got us here. Comms. So again, being the comms guy, I had to have this slide. But the fact is, you go back 20, 25 years, there weren't any standards. Everything was proprietary. Interoperability just didn't exist. You had to be inside the network that you put together, or else you couldn't communicate. So I think, from my point of view, I just think Bluetooth and Wi-Fi, I mean, they've had cycles. For a while, Bluetooth was interesting. It was a keyboard and mouse technology. Yeah, that's real nice. There were a couple companies like Logitech that sort of made a living on it. But then all of a sudden, another cycle comes and it's like, wow, with a little less power, and a standard that everyone can sort of swallow for applications that don't need ridiculous amounts of sort of broadband, could be pretty good. Now all of a sudden, Bluetooth is it. It's everywhere. It's our short distance protocol. Yes, there's Zigbee, didn't quite win out, is still there. There's a few others, but it's really made the day. And then Wi-Fi, I don't think anybody realized how many legs Wi-Fi would have. As a matter of fact, I just saw a headline on my phone. I get all these, like we all do. You get all the e-letters, that come into the email every day. And one of them said, Wi-Fi taking over the world from small cells. So the cellular industry, was the 900-pound gorilla, right? And if you wanted to talk to anywhere, you wanted to connect anything, you had to work through the cellular operators and do all of that. And Wi-Fi was just this little thing for local area networks and for home. Now, every cell site that's going to be put out there in the next 20 years is going to have Wi-Fi in it. And anytime you can offload, you're going to do it. And in lots of applications, you don't even go wide area. You just stay Wi-Fi. And now outdoor Wi-Fi has come back. So, and it's also spread in terms of, well, maybe it's too high power for wearables, but there's low power Wi-Fi now. There's all kinds of variations. So these two protocols, I think, have saved our bacon. I mean, it's really wonderful how, after a certain amount of time, people were able to come together. If you think about even the wide area industry where there were 15 different cellular protocols, over the years, I think people have finally realized, and sort of economic economies of scale have just brought us to, there's really only a couple of protocols in the world, LTE being sort of the biggest one, that has just made life easier for everybody. Of course, there are a lot of losers who weren't there, but the fact is, you know, for the masses, having a single protocol that interacts and interoperates everywhere is pretty darn good. We talked about, so my very coarse definition of wearables, transducer, processor, comms, the ubiquitous availability of sensors, MEMS, you know, semiconductor technology that allows you to create temperature sensors, vibration sensors, gyros, all kinds of things, and be able to buy these things very, very, very inexpensively, and being able to mass produce them has really gone a long way to push this wearables market forward. And that's just happened really, really fast. Precise positioning. So having situational awareness. If you're wearing something, it'd be kind of nice to include, well, where are you? Doesn't always do that, but could. And I think, you know, having been, you know, in the GPS world for a long time, but now everything is all about sensor fusion. It's just like in analytics, bring in as much data as you can and then process the heck out of it. Well, in positioning technology, that's exactly where we are. It's not just GPS, it's Wi-Fi triangulation, it's dead reckoning using accelerometers to, based on a known given location, how far you've moved in an XYZ direction, and then fuse all that data together to get the best possible position in any scenario, indoor, outdoor, just basically just anywhere. And so the fact that you can do this, you can do it in real time locally, you can post-process it, you can send intermediate data and process someplace else, really wonderful things. And so I think that also is sort of added to the toolkit for wearables to make it easy to provide a pretty important function. Storage costs. Well, if you're going to put sensors everywhere and you're going to communicate them to somewhere, you're going to have a lot of data. And I actually didn't spend a lot of time in the presentation talking about video data, but you could, and we know how that just exponentially increases the amount you have to store. But the fact is, storage costs have just gone through the floor in terms of dropping, right? And so that's, again, another argument for another piece of the ecosystem that's sort of in place, that if you're going to monitor someone's life and monitor their flow and do that with hundreds of millions of people, you have to be able to store the data somewhere. Processor performance is up. The little anecdote I could share with you, so I ran a company, wasn't particularly successful I might add, but it was called Vidiant. It was in Santa Clara here. It was a spin out from NEC, and it was a sports technology that kind of followed the puck or followed the baseball, you know, so you could, when you're watching it on TV. Anyway, the company morphed into a physical security company, and basically it used a neural net-based algorithm on a very hardcore processor behind video cameras. And you'd use it at the airport to see if someone's walking the wrong way in the exit lane, or an unattended bag on a train platform because of the whole 9/11 thing, or just literally perimeter security around an enterprise. eBay was actually one of the first customers, one of the very few enterprise customers. Pretty much the only customer we had was TSA, and that sort of spelled the end of the company. But it was sure fun stuff. But the interesting part is, this is how hard it was. This was in 2006, right? So what is that, 8 years ago. There was I don't know if some of you will remember this, there was a company called Stream Processors. It was a network processor company, so sort of a general purpose processor that would do FFTs and things like that. It was the only startup it was the only product anywhere that would do the processing of our neural net. It was 20 gigaops per second to do a single behavior on a single camera. And that was $5,000. That was 8 years ago. So just to see if there was any people standing around a piece of luggage was $5,000 just to do that. Now, if you wanted to see if someone was walking the wrong way on the same camera, that's another $5,000. you could see how it maybe didn't work out real well. So but you know, we were always looking for new technology. But when you think about now, as a matter of fact, one of the I guess members of the organizing committee of the conference here today was with me at Canesta. I wasn't the original investor, but I was on the board from Venrock of Canesta that did actually the way to characterize it would be the second generation Connect technology. Not the first, but the second. We had really cool stuff. It was a little too expensive, a little too ahead of its time. Company was sold to Microsoft, and now is live in the products. But the punchline was gesture technology has just moved so fast, and now people are doing the kind of gestures I was talking about doing 8 years ago that just cost thousands of dollars. You can do them on the processor, on your phone with a single optical camera without even having any special sensors, lasers or photo detectors or whatever. A lot of progress. I thought this was worth mentioning because it's a unique company. We're not invested in it. There's no advertising this morning. I'm not going to do any shameless advertising. But there's a company out in Canada called Foamic Labs, and it's literally guys right out of school, undergraduate school, that created some super low noise. It's analog circuits. It's just low noise amplifiers that sense the voltages that are sent from your brain to your muscles. And you wear this strap right around your forearm, and as you move your fingers, you can actually train a processor to know 1 digit, 2 digits, 3 digits, 4 digits, moving up, moving down, moving sideways. It's very cool, right? But the whole, I wouldn't call it a resurgence. I gave a talk at the IEEE Signal Processing Society. A few of my friends restarted that group locally, but signal processing has always been around. It never really disappeared. But I'd like to say that with the resurgence of wearables and Internet of Things and just the interfacing with the outside world, analog to digital, that there has been kind of a resurgence and an awareness of the importance of signal processing and algorithms. Even you hear the word algorithms more because people talk about it with big data. So I just think that this was very representative of very, relatively simple but very sophisticated sensors, and then process the heck out of it and achieve a functional outcome. Then big data. So just big data on its own. The fact is, I talked about kind of sensor fusion, but you could sort of extend that term and say it's not just sensor fusion, but just data fusion. And people have known this for a long time. When I was working on my PhD at UCSB back in the mid-'80s, we were working on multi-sensor fusion for military contracts. It was very expensive, it wasn't really practical, but the idea is if you had sensors all over a battlefield and you could hear things and see things and you brought all that together, you could make better decisions. Well, now all that data is available to everybody, to some degree. I guess some places you're not supposed to get it, and that's where security comes in. But the net is, there's a lot of data out there, and it's very available. So the fact that we've got, in the wearables industry, we sort of have this concept that whatever data we need, we can get. Whether it comes from us, on the wearables from our bodies, or it's integrated with the weather, or the location, or the time. You can integrate all these things. Well, yes, that's great if you've got the data. The question is, can you process it? And I threw this in just because this is probably one of the hottest markets on Sand Hill Road where all the VCs live. Wearables I'll talk about in a minute, but certainly one of the hot markets now is just literally the ability to analyze large amounts of data and software and infrastructure that basically has come together very inexpensively to do that. So I think that's another reason why people can get excited about wearables, because you can collect the data and you can do something with it. And you can actually process it reasonably inexpensively. And then sort of the Internet of Things, obviously it's kind of a sister buzzword, right? Or a sister technology. But I would say because of a lot of the same reasons, and the fact that that market is also, and you could say that wearables are a subset of the Internet of Things, of the 30 to 50 million devices and that kind of stuff. But I wanted to point out that if people don't even think about wearables, they think about Internet of Things, so we sort of get the extra bump there. It's a bonus. And then finally, some wonderful things have happened in this time we're living in 2012, 2013, 2014, is stock markets have been pretty good, which means companies go public, which means the people that put money, the limited partners, into venture capital firms whose companies go public get paid back. And when they get paid back 10 or 20% per year return, they say, well, this is pretty good, I'll give you some more. And that's what's happened. So there's been, in 2014, I think there's been more venture capital funds created. I just heard this yesterday. More venture capital funds created than any other year since 2000 or since 99. Now that could be scary. I'll let you figure that out. But anyway, that's where we are. Who knows? Maybe we'll stay there long enough to all make money. And then things like Kickstarter and Indiegogo, crowdfunding, crowdsourced funding, especially in the hardware business. Because I think we all recognize, I mean, most people in the room here probably are software people to some degree, and there's probably some hardware folks here. I'm a long-time hardware guy. I can't tell you what I programmed in, you wouldn't even remember. But anyway, the fact that how do companies get started? Well, they need money. Well, how do you get the money? You convince investors that you've got something interesting. Well, how do you know you have something interesting? You show it to people. Well, if you can code up something real simple, and you could do that in a month or so on just your time, you can show software. But to build hardware, it's actually gotten easier, and we know there's 3D printing and all these kinds of things, but the fact is you have to build inventory, and it's just not as inexpensive. Well, if you can raise money on the come from people on an idea you have that requires a certain amount of money to get started, what a wonderful thing. So I think these crowdsourced, if they've helped anyone, they've helped hardware companies. And especially hardware companies that have modest products. We're not talking about Cisco routers, right? There are switches that cost $20,000 or cost $20,000 to build, and you sell them for $50,000. We're talking about devices that are cost of goods of a few dollars, $5, $10, $100. You can do it. You can raise hundreds of thousands of dollars and you can build stuff. So it's really helped. All right, so markets. I guess, how are we doing on time here? Let me back up. I'll zip through the rest here. We're good. Okay, so markets, verticals. There's probably a lot more than this. The ones that came to mind really quickly, there's probably one more in here. So consumer, enterprise, medical, government, maybe industrial, but I sort of mixed industrial and enterprise. Not exactly the same. But I think the important thing to remember if you're trying to start a wearables company, or you're evaluating wearables companies, or you're just looking at where you might want to work, all these motives where you'd have to sort of analyze, is this an interesting company? I guess the first thing I'd say, first and foremost, is in the consumer space where there's a lot of activity, is it a nice to have or a must have? The classic early stage startup question, what are you actually building? It's really nice to be in the place where people have to have it. I have a colleague that's just joined Venrock, and he had a one-liner, and it's, if you're not awake now, this will wake you up, but it's my favorite new graphic statement. So when people say, where's the pain, when you're trying to decide your product and does it fit, I like the, who's bleeding from the neck? That just says it all. You need it now, you need it fast, and it has to fix the problem. So you can borrow that, it's a freebie. Enterprise clearly is an ROI thing. Companies make decisions 90% of the time. Does it help their bottom line, or does it not? In the medical community, it's not a bottom line thing, it's more of a function and reliability. Doctors will use wearables if they think it helps them, and if they think it helps them save lives or do their procedures easier, and if they can trust it, because they're not going to do anything that shuts off halfway through the operation. right? Or probably shouldn't. And then the government, whether it's for military or whatever, it's probably reliability and performance. If your tech is better than the other guy's tech, maybe you'll be better off. So I found some cool pictures. I didn't even package, insulin pumps and vital sign monitors for a long time. The wearables market's just going to push that forward. I guess in the last couple of years, I've seen a lot of baby technology related to the onesies that would have temperature and moisture. I got to tell you, this it just jumped into my head. I'm not joking, and you have to be very serious about this because it's a huge market. But there's a company in the Valley that's doing smart diapers. I don't have to tell you anymore. You get the idea. Okay. So, all of us, when you go, most everybody in the room here has gotten a rental car. There's been wearables in that market for a long time. They wear the printers, right? They wear them on their belt, and you thank you, sir, and here's your receipt, and boom, 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 and so this is more of a door-to-door field sales thing. But anyway, the concept of wearables has been in that industry for a really long time, and the military is just the obvious one. I just threw up I just wanted to make a few comments about a few different, I think this company is here today. Is Misfit here today with the Shine? Yeah. Hey, bud. Free promo. Yeah. The fact that you can make very small sensors look very attractive and very simple, very unassuming, however you want to describe it, kind of a neat thing. And I think one of the more sort of visionary approaches to sensors. As opposed to the watch business, we looked at the Dick Tracy watch. That concept has been around for 60 years. I think it's going to be interesting to see how this plays out. I mean, you've got the iWatch. We'll see what that does to the Pebble. But the fact is, this is not exactly a new idea. So one of the comments I'll just throw in here, when you're thinking about your company ideas or where you want to go to work or where you want to invest, this is about sticking the stake right out there. This might be a big company play now. It just may be. It's not a new idea. The Google Glass thing, certainly interesting. I'd sort of put that up there with the Palm. It works. It does what it does. It seems like it's been sold as a technology, not really as a solution. And it's a platform, and platforms work across other things. So there'll be some areas where it'll work well, but we'll see. The virtual reality, augmented reality markets, some pretty interesting applications, but clearly this goes back to remind me the difference between the cell phone that took up the entire trunk and the cell phone and the watch, right? I'm not sure, this is probably halfway there, or maybe it's only 2% of the way there. Now the next three slides, three different companies, Fitbit, Microsoft, and Nike, right? So this has to do with the differentiation and the big company thing. And does it solve a problem? I mean, my understanding, Fitbit's kind of had their problems. They put it out there, and then there were skin rashes. They didn't have the right materials, and they had to have a recall. Do you want is it a watch? Is it an activity monitor? Is it a notification? I'm not sure if this market isn't, at least this product isn't a big company thing, and it's kind of, its time has come and gone. It's just not obvious. I mean, it seems like it's an intermediate stop. On that thought, there's actually a company out there, there's more than one actually, that makes the Fitbit kind of product in a ring, which is the most amazing thing. So what is that, like 10 orders of magnitude smaller? But it's all the same functionality in a ring. I thought that was pretty cool. So I'll just zip through the ecosystem questions, and I'll finish up and I'll take questions. Wireless charging. I'm going to show you a picture in a second of a really cool company that's doing something kind of neat. But if you've got all this stuff on you with batteries in it, I guess if the batteries last 10 years, there's no problem. So you just have to kind of make sure that it's got enough life that you don't have to think about it. But a lot of this stuff does need to be charged, and that's a real barrier to entry in terms of people will charge it for a day or two and then they forget. That's something you have to think about. Continued growth of big data, how you can use it. Interoperability. well, if this is Bluetooth and this is Wi-Fi and they can't talk to each other, I think people are making a lot of progress that way. I just wanted to point out that if we have multiple wearables and you're trying to connect to your smart home so your house knows where you are and knows what's going on, interoperability is always a big deal. There's always a big deal between Wi-Fi and Bluetooth. Everything has to be tested to make sure it works in one in the presence of another. Security, if all this data is going to float around, you can't let the bad guys get it. Environmental performance. There's this, I guess I'm not wearing that watch today, but I have a watch that my dad gave me. It's nothing fancy, it's just one of these diver's watches, so it's a Casio, not $50 watch, but the cool thing is, I wear it in the shower, if I go on vacation, I could swim in it, I could do whatever. It's kind of nice utility. A lot of the things that we're talking about, you may not want to wear it in the shower, but it certainly has to deal with heat and cold, may have to deal with water, may have to, obviously it has to be the kind of materials that aren't going to affect your skin and allergies. There's a lot of issues there. Cost of communications infrastructure, obviously Wi-Fi and Bluetooth pretty inexpensive, but if you have to build infrastructure in the application area where you're going to be, it was like Venrock invested in a wearables company called Vocera. It's a public company now. It's literally the Captain Picard communicator. And they decided to focus on hospitals. Well, when they started this company 6-7 years ago, the problem was hospitals didn't have Wi-Fi networks. So before they could sell the Vocera thing, they'd have to get somebody in there, an integrator, to put a Wi-Fi network up. So that's kind of an issue. And just the rate of change of technology, kind of what I was saying about the Fitbit, Nike Fuel Band, Microsoft, I forget what their name is, maybe called Band, I think it's called. Just the rate of change of technology, you have to think far enough ahead to make sure that when you're done and when you're in market and you're GA and everything, all these problems have been solved, that you're still relevant. And I think that's a significant question that you have to ask yourself. Because as much as you'd like to think you could start a company and in a year or two have a product, our experience looking through the rearview mirror after 500 companies at Venrock, it takes 5, 6, 7 years. So just have that vision. So anyway, just one cool thing about wireless charging, there's a company out there called UBeam. We're not investors, but it's pretty cool. They use beamforming and ultrasound to literally, they wirelessly charge through sound waves. And so there's a little pad on the back of your device, and as you walk in the room, there's infrastructure on the ceiling, and you can charge from there. It trickle charges batteries. Very cool. So, tips. Got to follow your passion, number one. I'd never take that out of the picture. If you're not passionate about what you're doing, what your work, where you go to work, what company you're doing, what you're investing in, all of the things you all do. Investors follow the money. This goes back to who's bleeding from the neck. It's nice to build fashionable products. Consumers get excited about things. There are fads. But if you're building the enduring product, want to change the world, you got to make sure you're solving a real problem. Work to be highly differentiated. Enabling technology matters. So just think about it. If you've thought of something and you're using a Hadoop cluster for this, there's probably 50 other companies that are probably doing that too. I'm not saying that you shouldn't use that. I'm just saying you need your hook. You got to have something. Look for achievable entry points. There's a guy named Jeffrey Moore, a famous marketing guy who wrote a bunch of books, The Gorilla Game, Inside the Tornado, Crossing the Chasm, and it was all about if you're building platforms or if you're building new products, you got to have a beachhead. Find an application that just works. And I mean, for example, in the robotics world, trying to make repairs in nuclear plants. No humans want to go into nuclear plants anymore because they're afraid. Well, if you send a robot in there, it solves the problem. Easy solution, easy, easy application, and no questions asked. Finding entry points in the cloud, find a place where your first adopters, they just got to have you, or got to like it, or whatever. And venture activities focused on solutions. There's a lot of components companies out there, materials companies, accelerometer companies, but the majority of investments these days, I guess it's just the way the world is. Investors, I guess it's, you can see, you don't count on anyone else to be in the way of you getting to market. if you sell to the end user or close to the end user, you can get to the market. You'll understand the market more quickly, you'll get feedback directly, and arguably you can control your own destiny. So I think that's it. But thanks for listening, and enjoy your day.
Thanks, Steve. Thank you so much for your knowledge and expertise. I would call Sudhir, he's Vice President of SIPA, on stage to just give away a certificate or word of thanks to you, and then we'll move forward for Q&A.
Thank you. Thanks, Steve. So Steve was my board member at Canasta, and it was fun to be with Steve at Canasta. Successful exit, sold company to Microsoft. That was fun, and more to come.
Yep.
Thank you for coming, Steve, and thank you for your time.
Welcome.